Okay, so in this video, I'm going to show you how to do a kind of diagram drawing a bunch of normal vectors away from a geometry and color them according to surface curvature. So we're going to use this project, the Church of Christ the Worker by Eladio Dieste, as the example. And first thing that I'll do is reference it into my Grasshopper file. So I'll go to Geometry, go to BREP, place that on the canvas, right-click that one BREP and click on that model. Now I have one joined BREP. If you have separate surfaces, you could insert them separately using a surface component. And I'm just going to hide the base geometry there in my view. Then I want to deconstruct this into its individual faces. So I'm going to go to the Surface tab so we can see more. Surface tab, and I'll go to Analysis and get a Deconstruct BREP. I'm going to break my surface out into faces, edges, and vertices. And then I can take the individual faces, there should be 3 here, divide them using a surface subdivide. So I'll go to Utilities, Divide Surface. So my faces is going to go into the S input on my surface divide. The other thing that I want to do is actually measure the dimensions of these surfaces and base my subdivision values on that so that I get a kind of even spacing of points. To do that, I'll go to Analysis and go to Dimensions. So that'll give me like a UV dimension. And then I need to divide those dimensions by whatever increment I want to apply to the spacing of my points. So I'll go to Math, Operators, and get a divide division. Right? I'll place that, plug the U into the A. Now I need a number slider. What's the increment that I want to divide by? I'm going to just double click on the canvas and type in 5.00. Start with that and see how that looks. Plug that into B. And then I want to just copy paste the division, Control C, Control V. And also drag and tap Alt on the keyboard. And I'll plug my V into that as well. So I got one slider controlling both my divisions and plug those into the UV on my surface side. So now I should get more points the smaller that number gets and larger it gets, and that number should be roughly how far apart each of these points is on the surface. Okay, I should have a grid of points. Then what I want to do is create a series of vectors. I'm going to go ahead and select all this stuff, right-click somewhere in the empty space on the canvas and preview off. Just seeing the points in my viewport. I'm going to get go to Curve, go to Primitive, go to Line SDL, which stands for Start. That's a point. I'll plug that into the P on my surface divide. Direction, that's a vector. Plug that into the N, which is the normal vector. See, we're already getting lines there coming out of our surface. And then I need to give it a length, which is just a number. Double click on the canvas, type in 5.00 again. See what that looks like. Okay. So I'm going to unpreview my surface divide so that I'm not seeing the points, I'm just seeing those lines. Now, one thing that I want to fix actually before I go much further is if I preview my original BREP again, preview on, see all my lines are being drawn inward. I'd rather that they're drawn outward. So what I need to do is flip the direction of my surface. I'll go to Surface, Pink, Utilities, and Flip. And I believe I need to place that between the deconstruct and everything that it's plugging in. Well, maybe let's try the BREP. Maybe. No, doesn't like it. Never mind. So plug the F output, S, and then the output of that into our dimension and into our surface. And the result of that should be all our lines are now pointing outwards from the surface as well. All right. So now we're ready to, we have a bunch of lines sticking out of our surface. We can change how long they are. We can change how many of them there are. What we want to do next is color them. So I'm going to use a technique of just measuring the curvature of the surface. So I'll go to Surface, under Analysis, and I'll go to Surface Curvature. Now, what surface curvature wants is the location of each of the points where I'm measuring the curvature, and that's actually a value that our surface divide gives us as well. So I need to give it a surface. That's way back here where my flip is. Then I need to give it the UV parameter or the location of each of those surface curvatures. Now we're having an issue here because we have what is essentially an unflattened list coming out of our flip component, and we have a grafted list with many branches coming out of our UV, which some of those addresses there. So what I'm going to do is I need to, well, let's try and graft our S input on our curvature and see. That should put each of those into a different branch. And then the other thing, I wonder if that's doing what I want. Our output is I think the other thing we need to do is see if so our UV parameter has a bunch of addresses to it. So that number there is going to represent which surface we're looking at. That number is going to represent which row of points. Fewer points here. It's long of a list. If I scroll down, you'll see I go all the way up to, there's one, that's our second surface. Anyway, we need to get rid of this layer of our branch. So to do that, I'll go to Shift Paths. So type in Shift and Paths. Plug the UV into that. Now, if we look at the addresses coming out of this guy, you can see we have 4 numbers in those addresses, 0, 0, 0, 0, all the way up to 0, 0, 2, 4. If I look at the output of this guy, I have 0, 0, 0, 0, 0, 1, 0, 0, 2. And that should be exactly the same as what I have on my surface there. So now the kind of structure of each of our lists matching. And when I plug that in, you can see this component's much happier. All right, now all we need to do is color each of our lines using the curvature measurements that we've gotten from our surface curvature analysis. So next thing I want to do is look at there's 2 types of curvature. It's measuring what's called Gaussian curvature and mean curvature. And we could try them both, but basically they're just numbers. It's just telling us like a degree basically of curvature. So what we're going to do is we're going to use that as the range of a gradient to preview our geometries at different colors. So first I need to get the bounds of this list, minimum and maximum. I'll go to math, your domain, and I'll get a bounds component. That should give us a domain that represents the minimum and maximum curvature values of each list. And then I also want to get a deconstruct brep, again under domain. Deconstruct, I'm sorry, not brep, domain. So your domain, deconstruct domain. So this is a minimum and maximum, some number to some other number. And we want to deconstruct that into the start and end values as independent values. starting end. And that's going to drive our gradient. So I'll go to input, we'll get a gradient. So L0 is going to be our start value, L1 is going to be our end value. And then T is going to be the actual curvature degree. And then finally, we need to actually apply this color to our lines. To do that, we'll use a preview component. I'll just type in preview, the search bar, custom preview is what we want. So it asks for a geometry, that's our line, and a M value, meaning a color. If I plug that in, you can see it's giving us a range of colors. It's down a little bit so we have a greater density. So a couple things. Let's change to a different preset because we only have two colors right now. So I'll right click on the gradient and I'll go to presets. Use this one, nice orange to blue. All right, now we have a broader range there. But I would also like to basically flatten all my lists, because what's happening is I'm comparing the curvature values for each surface independently. That's why I have 3 branches coming out of this bounds. So what I want to do is flatten the output of my surface curvature and flatten my line segments. So right click on the L, hit flatten, right click on the G, flatten. Then it should start to give us a range of color that kind of moves across the whole surface. Like that. And let's try the M as well. So I'll make sure I flatten that first. Right click, go to flatten. Plug that into my bounds. Plug that into my little T on the gradient. Somewhat different result there. All right, so that's one way to color those lines. And if you want to change any of that, you just double click on your gradient, click on one of the points, and then I can edit the color of that point. I can use a custom color, go to web and draw from a list, or I can go to system and draw from a different list. All right, that should conclude this video.